Hello and welcome to this episode of Next Review. And for this tutorial, I'm going to go over a Terraform project. So I'm gonna go over the resources that I created and how I have everything set up as infrastructure as code. So this goes from VPC, the different subnets, um, the different route tables. I have everything set up, and also the EC2 instance, which is the virtual machine that I created within the private subnet to host a web server. In this case, it has Nginx. It's going to have Nginx installed in it, and then we're going to see that on the browser as well. So this is everything set up as a code. So rather than having to create everything manually on the console, and then let's say you have to make modifications, you have to remember where everything is. In this case, you have everything on the code. It's easier to make any modifications that you want. It's also easier to create similar infrastructures or similar environments, much faster because you already have this configuration as a code. So you can just go ahead and make some changes, some modifications here and here, and then, or maybe just change some variables, and then you have a new environment spinning up. So it makes things that much more convenient. You're able to create new environments much quicker once you have the initial one already set up. So yeah, so this is the code. So I have different resources within different files here on the left. So I'm gonna go ahead and start with the provider file. So the first section here is just it tells you that we are using Terraform, and it gives you the version of Terraform that you need to use. And then we're using AWS. And then down here, the configuration. So here we have, so I'm using a particular type of credentials. This is the profile credential, or it's called the share credential. So in this case, I'm not going to show my credential files. I'm not going to show the actual keys that I have just for privacy, but it's pointing. So this is the variable of the profile, and this is within the credential file. So if I have these things, it's at the AWS folder. And then within that, I define the keys, the secret and private keys, and it has also the region defined. So this is the Terraform knows where it's going to go to create these resources, right? It knows the region, and it knows from the keys, it knows the accounts where it will go in and then create these resources. So that's what these things is defining. Pretty much telling Terraform, go to this particular account, and then you're gonna create the resources within that account. Okay, so that's the provider file. Okay, so and just another word and note. So I didn't write anything from scratch. Again, what I did was, I think you go to the HashiCorp website, and you can search this resource that you want. You'll get a template of the resource, and then you can make the modifications based on what you need, based on the configuration you're trying to set up, so you can make the changes as you see fit. Or I also use Amazon Q, which helps you generate codes for the resources, and then then after that, you can make the necessary modifications that you want to make so that it meets your criteria. Okay. So that was just a parenthesis. Okay, so this is the provider file, and let me go next. Let me look at the VPC. So here we have our VPC, our virtual private cloud. So we have the name of the VPC, in my case, is Congo. And we have the starter block of the VPC 10.10.0.0/16. And instance tenancy is just default. And we have tags from VPC. So this is a VPC. It's going to create a VPC with this starter block. Okay. So we have a VPC. And next, let's look at the subnets. Actually, for the subnets, let me look at the internet gateway. So as you know, the internet gateway will be attached to the VPC. And this will give our VPC access to the internet. Okay. So we have the internet gateway resource. So I named the Congo IGW. And here, of course, this one defines what the resource is. In this case, it's the internet gateway. And then here, of course, you associate the VPC that we have here that we just went over to this internet gateway. So we have VPC ID, and this is our VPC. The name of VPC is this one, and the ID. You just add ID at the end. And it's going to associate the VPC to this internet gateway, or it's going to associate this internet gateway to that VPC. And this here, we just have a tag for the IGW. And next, let's look at some of the subnets that we have. First, let's look at our public subnets. Let's see, public subnet. Okay, let's see. I have two public subnets. So I have so I have a comment here. It says public subnets, one in availability zone 1A. And here the second one is I have in availability zone 1B. Okay. I mean, for this particular project, I only created one virtual machine. So that was the only resource running within the subnet. So it was not really necessary in a way. But this is just to demonstrate how you can create multiple subnets and things like that. So I have a subnet in availability zone 1A. So public subnet, just the naming. I have in public subnet A, just to reference that it's in availability zone 1A. This is the VPC that's associated with this public subnet, so the VPC ID. So the block of this subnet. So again, it's going to start with 10.10 because our VPC, if you remember, the VPC starter block began with 10.10. So everything within the VPC will begin, every starter block within the VPC will begin with 10.10. So everything will begin with this. And for this for this particular subnet, there is a 1 up to the 2 10s. Every resource that would have an IP address within this public subnet will begin with 10.10.1. Okay, everything will begin with 10.10.1, and then this is what's going to change. Okay, so in our case, it's going to we have 256 available IP address within for this particular subnet. Okay, and the availability zone US is 1A. Okay, so that's public subnets 1A, and then we have public subnets 1B. Okay, so we just have the name here, public subnet B, and the VPC ID. It's the same VPC, so we associated with this VPC that we created earlier. So VPC ID, or I should say the one that we have defined, because nothing is created yet, since everything is stored as a code. So it's just defined. Okay, once we launch everything, we apply the codes, and then everything will start being created. But now we're just doing the associations. This is just the association. So these things need to be associated with the with this particular VPC. So we have the VPC ID here. The starter block in this particular case, it's 10.10 and 2. We are 10.10 and 2. So everything within this subnet will begin the IP address. I mean, every IP address within this subnet will begin with 10.10.2, and then you have the 0 here, which this will be the thing that changes. Okay. These ones will remain the same. And then you have these last digits will be changing. So it will give us a 256 available IP address for these particular subnets. Okay, so that's that. And then of course it's going to be US East 1B. So this is the availability zone we're defining US East 1B. And here we have US East 1A. So we're defining the different availability zones in which they're going to be created. These are our subnets, public subnets. And we can also look at a private subnet. And just a quick note, as for now, nothing is truly okay. As far as I have shown, nothing is defined as public or private, okay? So those things are defined by the routes and the route tables and the route table associations. So I'm gonna go over that after I'm done going over the subnets themselves. So for now, nothing says that there's nothing here that tells you that this is actually public, that there's nothing that's defining it as public, just by looking at this particular file that I'm looking at here, okay? So let's look at the private subnet. Again, so I have a comment made, private subnet 1 in availability zone 1A. And then we have here on the bottom, I have private subnet 2 in availability zone 1B, okay? For this particular project, I don't have any resources created within the private subnet, but if I did want to create something, I'll have them available. So I can always choose to add resources within the private subnets, things like backend resources or database, things like that. So I have my AWS subnets. So I'm defining it as a private subnet. Again, if you can notice, it says the resource is called AWS subnet, it's not called AWS private subnet or AWS public subnet. If you notice, I'm using the same thing for the public subnet, it says the same thing. So they are not inherently defined as private or public. So that comes later. That comes when I set up my route table and my route table associations. That's when I'm able to define certain subnets as public and certain subnets as private based on the route. So as for now, so it's just the naming really that's separating between, that's differentiating a private and a public. For now, just the naming. As far as I've the things I've already gone through, it's just a naming that's differentiating the two. So here I have something I'm calling private subnet A. And then on the bottom, I have something I'm calling private subnet B. So here I'm defining the SATA block 10.10.3.0.24. So everything within this subnet will begin, the IP address of everything within this subnet will begin with 10.10.3. And then we're going to be changing this very last octet. So then again, we're also going to have 256 IP address available, which that's the reason why we have 24 here. So it blocks all these three, the 24 here. If you remember, for the VPC, it was 16. So it was only blocking the first two. And in this case, we have 24, so it's blocking these three. So these three are going to be constant. And this last one is the one that's going to be changing. It will give us 256 available IP address, or so it's 2 to the 8th. So that's that. And then we have the availability zone. I'm going to create this within US East 1A. And then I have my second private subnet, which I'm creating in US East 1B. Okay. And so these are the subnets. So now let's look at the route tables. So first, let's look at the public route table. So here I have a resource called AWS route table, which I'm calling public route table, just so we know, to make it easier to refer to. So you kind of want to give a name that's easier to understand by looking at it. a random name might make it just confusing. If I just give it a name like AWS route table, XYZ, somebody might look at it, it's like, what does that mean? It's like, okay. So I say public route table, so I know this is I'm referring to a public route table. And the VPC ID, so I'm associating this with the VPC called Congo. And the route itself, so we're going to define this as a public route table. So we have the routes. And so if you look at, so you have the public, if you look at the private, if you know this is called AWS route table. And if you know this is also called AWS route table. So there's nothing inherently different about these two. It's the same thing, but the routes option I'm choosing is defining it as public or private. Okay. So for this particular case, I have a public route table. Now, if you look at the routes, the route option, I have my destination as 0.0.0.0/0, which is the internet. This is the starter block for the internet, right? So I have that as a destination, and the target, the gateway ID is internetgateway.com. So this is the internet gateway. So I have my internet gateway and then the internet destination. And so this particular section is what's making this a public route table. Okay. And now if you go to the privates, and again, here we have the same thing, AWS, the same resource, AWS route table. Here now I'm calling this private route table. Again, I also have the same VPC ID associated with this. Okay. Now the routes, if you notice now the route is different. For the destination, we still have the internet. We have this 0.0. Okay, I just messed this thing up. Let's fix that. Okay, so you have 0.0.0/0.0.0/0 as for the internet. And then for the target, we have the NAT gateway. Now, previously for the public route table, we had the internet gateway. Now, the private route table, we have the NAT gateway. Okay, so as a target, NAT gateway. And this defines this as a private route table. Okay. Now we have our private route table defined, and we also have a public route table defined based on the route. Again, the public route table has as a destination the internet, and the target the internet gateway. Okay. And the private route table has within its routes the destination as the internet. The target now is the NAT gateway. Okay. So we have this now defined as public and private. Now we're gonna use these two. We're gonna use this private route table and the public route table to define the private subnet and the public subnet. So now let's look at our association. Now we have to create something called an association. So let's start with the public. So I have a file called route table association public. This is to define our public the two public subnets are created. So I want to define them now as public subnets. So until now, they were not actually defined. So now this is the file that actually defines it as a public subnet. Okay. So it is through this association. So here I have a resource called AWS route table association. Okay. And in our case, I'm calling this public subnet A. So this is for the public subnet A. And I have subnet ID. So now it's asking me, okay, which subnet do you want to associate with this route table association. And I say, okay, pub subnet ID, I'm gonna say public subnet A. So in other words, the public subnets that are created within availability zone 1A. Okay, so it's gonna get that ID, and then it's going to associate this with the public route table. Okay, so which route table are we referring to? I want to reference public route table. Davis route table, public route table that I've created. Again, this public route table has the routes defined as for the destination as the internet. If you remember, it was 0000/0. Or I should say 0.0.0.0/0. And then the target was the internet gateway. Okay. So now we are associating these subnets, public subnets within availability zone 1A with this public route table. Now this particular definition here is making this route public. This subnet now is now officially a public subnet because of this association and because of the definition of this public route table, because the routes that it contains. And then here we have another subnet. We have public subnets within availability zone 1B. And again, same thing here. So we're associating this with also a public subnet, a public route table. So the same public route table. So now these two are now officially, now these two subnets are now become, are now defined as public subnets. So now we have the same thing with the private subnet. So we have the private route table associations. So I have my private subnet within availability zone 1A, here right there. And so I have the subnet ID that I'm referencing is private subnet A. It's going to get that ID, and it's going to associate it with the private route table. Okay. And again, the private route table was defined as having the route with destination as the internet, and the targets was the NAT gateway. Okay, so now this defines this subnet is a private subnet because of its association now with the private route table that we defined, that we showed earlier with the route. And same thing with the private subnet within availability zone 1B. We also want to define this as a private subnet, and the way we do that is we also associate that with the private route table. So we have that, and then we have the route table ID that's being associated with this is route table, private route table. Okay. So now that's done. So now we officially have our public route table and a private route table. Of course, as codes, nothing is created yet. Everything is a code. Everything is defined as a code. Okay, let's see what else should we go over. We had the NAT gateway. Of course, I don't think I went over this. Yeah, so the NAT gateway, similar to the internet gateway. Internet gateway is we're using that for access to the internet, for public access, to give us access to the internet, to the public subnet. And the NAT gateway, it's for giving access to the internet for resources within the private subnets. Okay. And so this is just how it's defined: allocation ID, elastic IP. So it's going to create an elastic IP. Subnet ID. So we're going to place this. So this is the subnet in which you're going to place this NAT gateway. So we want to have a place within a public subnet. Okay. Because the public subnet has access to the internet gateway, or which has access to the internet. Okay. And this will give the resource within the private subnets if needed to access to the internet via the IGW. So we have that. And so let's see. Okay, this the dependency. So it depends on the internet gateway. So it depends on the internet gateway. So we're gonna need that. So this is the net. I don't have anything in the main file. Let's see. So let's look at the let's look at our EC2 instance. Okay. So here we have our EC2 instance, which I created within the which I have defined within the one of the public subnets. Okay, so this is a virtual machine. So I have the name Congo app, the AMI. So I picked an AMI. This particular one is an Ubuntu AMI. We have AMI instance type, T2 micro, key name. This is the key that it's going to use. This is the key that Terraform is going to use to access this, to log into this instance. Subnet ID. So we're gonna create this within the public subnet A. Again, by this time we already have our subnets defined, public, and all those things. So now we're just associating. So we're saying, okay, we want to create our EC2 instance within public subnets in availability zone 1A. So this is saying we're gonna give it a public IP address. So it's gonna give it a public IP. And then because we're going to install a web server, we're going to install Nginx, and then we're going to use that public IP to see the contents of our server. Okay, so that's that. VPC security group. We're going to look at the security group setup, but this is the security group that's associated with that we're associating to this EC2, and we're going to look at that next. User data. So this is what we're installing, the commands that we're running once we have this thing created. So we have a bash script here. So we're going to update the machine. So we're gonna do an update of the machine. We're gonna install Nginx. We're going to enable Nginx. Enable meaning that if we turn off our machine and then we turn it back on, Nginx is gonna come back running with the machine. So we won't have to go ahead and manually to start Nginx again. It will be automatic. It will be automatic because we have an enabled command. And system restart is just restarting Nginx. Okay. And this is just a tag name, Congo apps to instance. So this is our instance. And next, let's look at a security group. Security group, where is that? Security group. Okay, so this is our security group. We have a number of things here. Let's see, we have a number of ports open. Ingress, we have an egress. We have port 80, 422. Okay, and we have also about egress. Okay. So here we have security group. So the name is security group. Name we're saying allow SSH and HTTP. So now we allow SSH, inbound SSH and HTTP. SSH for to log in, HTTP from the web. Okay, inbound traffic. Again, VPC ID. So we're gonna associate a VPC ID. It's gonna be associated to this VPC ID, the security group. Egress meaning meaning traffic going out. So we're saying anywhere, so the block it can go in anywhere. So anything, this means any port, any protocol. So any port, any protocol can access the open web. Okay, so that's what this one means. And so this is for going egress, so it's traffic that's going out. And this is traffic coming in. This is for the ingress. So the ingress, so we have port 22, which is our SSH port, ATCP protocol. So start a block. So this is, we're saying that in this case, we're saying that any IP address can SSH into our system. This is not an ideal thing. You don't want to, normally you want to define a particular IP address to access your internet. Okay. So in this case, for this example, just open to everything. Okay. But normally you want to define a specific list of IP, a specific range of IP address, or or resource within a specific network that should have access to this, or maybe in the resources which have a particular security group. Okay. Security group ID, there is security group, called security group. So since this block is outside this security group block, so we're associating this. This is just one method of writing this. You can write the whole thing inside as the same block as well. But for this method, since it's outside of this block, so we're associating with this security group. We're associating this ingress rule, okay, with this security group. So we're saying that this ingress rule belongs to this security group, Congo SG. And this is our second ingress rule. In this case, we are opening port 80. Any traffic can access port 80. Okay, any IP address. Ooh. Okay. So that's that. That's what else can we go over? And as far as the state file is concerned, we have a state file locally here. Ideally, you want to have a remote backend setup, like an S3. Set up an S3. So I'm going to change this code. I'm going to change this, modify the project, and set up an S3 bucket for our backend for our state file, so that you're able to collaborate with other folks as well. Okay. And it's also more secure that way. And so from S3, then everybody who can use the state file to create or to have access to the infrastructure. Okay, so in this case, just set up locally. Sorry about that. Okay, so let's see what else we have here. So those are the main things I need to go over. Okay, now that's set up. I'm gonna go ahead and run the code. So let's do Terraform. Let's do Terraform plan. Oof, oh my. That's Terraform plan. And we are just waiting. Okay. And Terraform plan will give you an overview of the resources that you're gonna have created once you apply. Okay, so it says plan 18. So it's gonna add 18 resources. It's not gonna make any changes. It's not going to destroy anything. Okay. And we're gonna have an output. The output is gonna be an instance public IP known after apply. So once we have apply, we're gonna see the public IP address of our instance. Okay, actually, we didn't go over the output file. So let's just look at it real quickly. So this is the output file. It's a public IP address of the EC2 instance, digital description. The value is AWS instance.com app public IP. So we're gonna display the public IP of our instance. Okay, so we have that. Now let's apply. It's Terraform, apply, auto, approve. And we're applying our changes. This is the results that came from the Terraform plan. If you want to see the different resources that will be created. Now we just wait and see. And we can also go to the console and let's instance. Let's see if it's already created our instance. Because we know we launched an instance. Let's see. We have something that says pending. It's creating this. Pending, so it's being created. After some time, it's probably gonna say running, but it's not ready yet, so it's still being created. And this is going to be the public IP address. So now it's running. Okay. So now EC2 is actually running. And that's the issue initializing. That's the public address that we're also going to see if we look at the CLI. This is the output we're going to see 384.827. Let's go back to Visual Studio. Oh, it's still creating resources. This is not done yet. So we also can look at what else do we create a VPC. You can click on VPC. You see the VPC, Congo VPC. This is the VPC that we created. Okay. And check and see there's some of the details. Again, the starter block that we had specified 10.10.0016. So yeah. Let's go back. Okay, again, so 384.827. That's the public IP. You can copy this and check on the web and see if we can get our Nginx page. Because we are welcome to Nginx. So this is the web server Nginx running within our EC2 instance that we just launched. Once we destroy, we're going to reload this and we're going to see that we're not going to have any more access. But yeah, so we can also see And so we can see the internet gateway that we created is called Congo IGW. We can look at that. Your VPCs. See internet gateway, NAT gateway, internet gateways. We see our Congo IGW is also there. Let's see the route table. Where transit gateway. Let's see. Where's the route table? Okay, route tables. So we have private route table, public route table. Let's see. Yes, two subnets associated with it. Subnets. And it's related to Congo VPC. Subnet associations. Routes. So you're able to see different details. But yeah, so I'm gonna go ahead and destroy. Terraform, destroy, install, upload. Now it's gonna go ahead and proceed and destroy everything. So this is still running. That's begun to destroy. Let's see, load. Now we don't have anything running. IaC still running. Still running. It's destroying everything. We reload. So pretty soon it's gonna disappear. Not yet. Now it's gone, nothing running. Shutting down. It's now shutting down, it's deleting it. So now this one will be not able to connect. If we try to reload this, we're not going to have access to the page because we shut down the machine. We deleted the machine. Yeah. Now it says terminated. Yeah, this side can be reached. Okay. Of course, here it's still going over everything, destroying everything. And now we get the message, destroy complete resources, 18 destroyed. Okay, so that concludes the video. I think this was a little bit longer than I expected it would be. But yeah, that's just an overview of Terraform, creating things as an infrastructure as code. So it's much easier to make modifications. Let's say I want to launch a new environment. Let's say this was I don't know, a test environment, and I want to launch maybe dev environments. I can use the same code and make some changes where needed, and then launch. So I wouldn't have to create everything from scratch. So it saves you that time, and then and you have also the convenience of making using the code through a version control. So keeping all the history changes um, in your version control. So rather than creating things manually and making manual changes, you can use version control with this. Uh, be able to collaborate with different team members. Um, Everybody's making changes, then you submitting the request, and then it gets approved, and you do the merge, and then everything maybe can also be deployed to a pipeline. So you can have this being deployed to a pipeline as well. And then changes get approved, and then it gets pulled to a pipeline, and then it gets deployed, so things like that as well. So there's that convenience of using infrastructure as code. Okay, that's the end of the video. See you on the next one. Peace.